Hello class, today we are looking at section 5.1, factoring out the greatest common factor, factoring by grouping. Turn to page 313 and look at number 25. 25 says, find the prime factorization of each number, and we're on page 313. We have 288. One thing you may want to review over is your divisibility rules. It helps a lot with factoring. Timetables, make sure you are sharp on your timetables. That also helps you with factoring as well. I'm going to do just a simple factor tree, and I'm going to break it down to its prime numbers. I know that 288 is divisible by 2, and I know 2 times 144 equals 288. Break down 144, I know it's 12 times 12. Break down 12, which I know is 3 times 4, or I could have said 2 times 6. If I break down 4, I'll get 2 times 2, and then 2 times 3 for 6. Now, you want to identify your prime numbers. My prime numbers are the numbers that are divisible by itself and 1. The only numbers that are divisible by itself and 1 in my factor tree is 2 and 3. So I'm going to write down 2 times 3. We're going to count how many 2's we see. I see 1, 2, 3, 4, 5. So it's 2 to the 5th power. Count your 3's. I see 1, 2, 1, 2. So it's 3 to the 2nd. So my prime factorization for 288 is 2 to the 5th times 3 to the 2nd. If I multiply 2 out 5 times and multiply 3 out twice, and multiply those together, I should get back to 288. And that will let me know that I broke this down correctly. Now, let's look at number 31. It says, find the GCF of the given binomial. We know binomial means we have one term. I have 4AB and I have 18B. Thinking back to those prime factorization, if I break down 4, I know that 2 times 2 is 4. I have only one A and only one B. If I break down 18B, I know that 2 times 9 is 18. And if I break down 9, I know 3 times 3 is 9. So 2 times 9 is 18. I could have also said 3 times 6. And I would still got 18. Common factors is looking at both of these terms and seeing what do they have in common. I noticed they both have at least one 2 in common. And they have at least one B in common. So my greatest common factor is 2B. Number 33. I have 6x squared y squared, 12x y z, 18x y squared, z to the 3rd. When I break down 6x squared y squared, I have 2 times 3 is 6. The square means I have 2 x's. The squared means I have 2 y's. If I break down 12, I know that 2 times 6 is 12 and 3 times 4 is 12. 3 times 4 is 3 times 2 times 2. I have only one x, one y, and one z. If I break down 18, I know 3 times 6 or 2 times 9 is 18. If I do 3 times 6, I have 3 times 3 times 2. And that's 3 times 6 or 9 times 2. 1x, 2 y's, and 3 z's. And we are counting by the exponents. Again, we are finding our greatest common factor. So we want to identify what they all have in common. All 3 have a 2. All 3 have a 3. All 3 have an x. And all 3 have a y. But all 3 do not have a z. We're going to multiply what they had in common. 2 times 3 is 6. Times x times y. So they had a 2 times 3 in common, which is 6. They have an x in common and a y in common. And that is my GCF for number 33. (49) says, factor each polynomial by factoring out the greatest common factor. I have 4x minus 8. I have a binomial, so I have 2 terms here. And looking at the 2 terms, what do you see that they have in common? Well, I see they both can pull out a 2, but they can also pull out a 4. So that's where the word greatest come in. 4 is bigger than 2. So I want to factor out the 4. I could have factored out a 2, but I would be doing extra work. So you want to pull out the greatest so you can do less steps. The next step we're going to do is we write down what is left over. And to get what is left over, you have to divide. 4 goes into 4 one time, so x is left over. Bring down that minus sign. 4 goes into 8 2 times. You can check yourself by using the distributive property. 4 times x is 4x. 4 times negative 2 is negative 8. And that's how you can check your work very quickly to make sure you did it correctly. Number 61. We're still factoring out the greatest common factor. We have 24 x squared, y to the third, z to the fourth, plus 8x, y squared, z to the third. Right here, we have 2 terms, a binomial, and we need to see what they have in common. Now, you can do some side work for your coefficients to see what they have in common. Or we can think about those multiplication skills. I know 8 times 3 is 24, and 8 times 1 is 8. The common number was 8, so my GCF would be 8. On the x's, you will have to pull out what they have in common. This x has only 1. This x has 2. I have to go through x to the first to get to x to the second. So the common factor between x and x squared is just x. Look at your y's. I have 2 here and I have 3 there. I have to go through 2 to get to 3. So the common factor is y squared. On the z's, I have 3 here and 4 there. I have to go through 3 to get to 4. So the common factor is z to the third. If you don't understand that, you want to factor out the variable with the smaller exponent. And that would be the GCF. The variable with the smaller exponent will be the GCF. Now, if we're going up and down, we're dividing. If we're going across, we're multiplying. When I divide, we have to still remember our property of exponent rules. And the rule says that when dividing, you subtract the exponents. Now, when you're dividing your coefficients, you keep it very elementary. I know 8 going to 24 3 times. But when I'm dealing with the variables and exponents, I got to remember my rules we talked about in chapter 4. When I divide, I subtract those exponents. So I have to keep that in mind. Both of these have a base of x. 2 minus 1 is x to the 1. Both of them have a base of y. 3 minus 2 is 1. Both of these have a base of z. 4 minus 3 is 1. So we know that it's understood to be a 1 del. Bring down your plus sign. Now right here you want to be extremely careful. I know 8 divided by 8 is 1. I know that 1 minus 1 is 0. But think about our properties of exponent rules. What is a base raised to a 0 power? It is 1. 2 minus 2. Y to the 0 power is 1. 3 minus 3. Z to the 0 power is 1. So my number is 1. You must write a number here. So it is very important that you write something here. Do not leave that blank. So my answer is this right here. You can check yourself by using the distributive property. But again, you need to remember your properties of exponents. When multiplying, you add the exponents. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. And then 8xy squared z to the third times 1 is itself again. So very important that you remember those rules. When I'm going up and down, I am dividing. And when I'm going across, I am multiplying. So make sure you remember those. Look at number 63. On number 63, we have 3x plus 3y minus 6z. How many terms do I have now? I have 3 terms. So we are looking at a trinomial. Now, in all 3 terms, what do they have in common? All 3 terms I can factor out of 3. 3 divided by 3 is 1, so I'm left with x. Bring down your plus sign. 3 divided by 3 is 1. Bring down the y. Bring down the minus. 6 divided by 3 is 2, and bring down that z. And of course, use the distributive property to check your work to make sure you did it correctly. Number 71, it says factor out -1 from each polynomial. I have -x minus 2. Right here, I have 2 terms. They have absolutely nothing in common. So the only thing I can do is look at that leading coefficient, which is a negative, and factor out that negative. It's understood to be a -1, so I'm going to factor out -1. A negative divided by negative is a positive, so x is left over. A negative divided by another negative is positive, and then 2 divided by 1 is 2. And of course, we can check again. Negative times positive, negative, negative times positive, negative, and then 2. Do I need to see that 1? No, you don't have to see the 1. So my final answer may look like a negative x plus 2. Number 81. I have negative 25, x to the fourth, y to the third, z to the second. And I'm actually writing down 82. I want to write down 81, not 82. I have negative 4, a squared, b squared, c squared, plus 14, a squared, b squared, c, minus 10, a, b squared, c squared. We have 3 terms here. Now let's review. What is my degree? To find your degree, you count the exponents on the variables. I have 6 here, 2 plus 2 plus 1, I have 5 there. 1 plus 2 plus 2, I have 5 here. So my degree would be 5. Not 5, my degree would be 6. So your degree is your largest exponent. It will be 6. My leading coefficient will be negative 4. Look at all of your coefficients. What do all 3 have in common? Don't focus so much on the sign. Focus on that number. I have 4, 14, and 10. What do they have in common? All 3 coefficients have a 2 in common. But I do want to factor out the negative sign. So I'm going to factor out that negative and then bring down that 2. Look at the A's. Each of them have at least one A in common. Look at your B's. They have at least 2 B's in common. Look at your C's. They have at least 1 C in common. So this is my greatest common factor. What is left over goes in parentheses. To write what is left over, we're going to divide. And we have to remember that when dividing, you subtract the exponents. Very careful. We know that 2 goes into 2. 2 goes into 4 2 times. When I'm dividing, I subtract my exponents. So 2 minus 1 is A. 2 minus 2 is no B's. 2 minus 1 is a C. A positive divided by negative is a negative. 2 goes into 14 7 times. 2 minus 1 is A. 2 minus 2, no B's. 1 minus 1 is no C's. A negative divided by a negative is a positive. 2 goes into 10 5 times. 1 minus 1 is no A's. 2 minus 2 is no B's. 2 minus 1 is a C. And again, you can check your work by using the distributive property. When multiplying, you count the exponents. 1 plus 1 is 2. 2. 1 plus 1 is 2. 1 plus 1 is 2. 2. 1. 1. 2. 1 plus 1 is 2. And then, of course, we know 2 times 2 give me that negative 4. Negative 2 times negative 7 is positive 14. Negative 2 times 5 is negative 10. So all you have to do is use the distributive property and you can check it. When you're factoring out your greatest common factor, it's only going to take you a few steps to get it done. Number 91. It says factor each expression. These look a little different. I have x times x plus 1 minus 5 times y plus 1. Looking at this problem, how many terms do I have? I don't really know yet. I would have to distribute the x out and the minus 5 out to see how many terms I have. And I would have 4, unless I'm combining them some like terms. But I would have 4 terms there. So I want you to pay attention to that. I would have 4 terms if I distribute out that 5 and that negative 5 and that x. But I don't want to do that. That's too much work. I want to look at 91 into parts. My parts, again, will be separated by the plus and minus sign. I see a part here, and I see a part here. Look at the 2 parts. What do both parts have in common? They both have a y plus 1 in common. In my second parentheses, what did the first part have left over? A x. What did the second part have left over? A minus 5. And that is my answer. Right here, you can check your work. You would distribute the x, distribute the minus 5, and then you can do the FOIL method or box method here, and then you compare the 2 answers, and you'll see they're the same expression. $93. We have 3x minus y times x squared minus 2 plus x squared minus 2. Again, we want to look at the parts. The plus and minus sign separates the parts. This is one part. This is a second part. What do both parts have in common? They both have a x squared minus 2 in common. What did it not have in common? Remember, it's 2 parts. So when I look at this part, I need 2 parts in my leftover. In the first part, what was left over was 3x minus y. In my second part, though, what is left over? I don't see anything. It is understood to be a 1 here, so 1 is left over. And you must write plus 1 or it will be incorrect. So if you have 2 parts, you got to have 2 parts in the second parentheses. But again, with multiplication, it doesn't matter how I arrange this answer, it's still going to be correct. So if I was to write this set of parentheses first and this one second, it still would be correct. Because 2 times 3 is 6 and 3 times 2 is also 6. So when you're multiplying, it doesn't matter how you arrange your final answer. It'll still be correct. So far we have talked about greatest common factor. We are now going to talk about factor by grouping. On your homework, you will see factor by grouping when you look at 4 terms. And you'll also see factor by grouping when you look at 6 terms, which we will also go over in another note. Think about the word group. What does the word group mean? A group means 2 or more people. So if I look at 103, how many groups can I make out of 4 terms? Can I make 3 groups? I can't do 3. I can't do 3 groups because it's 2 or more make a group. I can't say 3 here and 1 there because this one is not a group anymore. I can't say 1 and 3 here. That's not a group. But I can say 2 and 2. So I can do 2 groups of 2. And that's how I want to set it up. I have 2 groups of 2. Look at the first group. In the first group, their greatest common factor is 2. What is left over is x plus y. And remember, in this process, I'm dividing to see what's left over. Bring down whatever this sign is. You want to bring it down here. What do these 2 have in common? They both have an a in common. That's my greatest common factor. What is left over? If I factored out an a, x is left over. Bring down that plus sign. Remember, addition doesn't change any signs. So make sure you understand that. I factor out of A, so y is left over. Now, 103 looks very similar to 91 and 93. So make sure you look at how they relate. This looks just like 91 and 93, this setup. And I already know that I had two parts here, so I got two parts here again. Now look at these two parts and tell me what's your greatest common factor. Both parts have a x plus y in common. And what is left over is 2, the plus sign, and the a. And that is my answer. And I can use FOIL method and I will get right back to my original expression. $101. And we want to go back just a little bit. Look at 3x times c minus 3d plus 6y times c minus 3d. So I want to go backwards a little bit on this one because I want you to see how we can do extra factoring in a problem. Again, the plus sign separates the parts. So this is one part and this is my second part. What do both parts have in common? They both have a c minus 3d in common. What did they not have in common? They did not have 3x plus 6y in common. But when I look at it the second time, they do have something in common. In the second part, what can I factor out of 3x plus 6y? I can factor out a 3 because I got 3 and I have 3 times 2. They both have a 3 in common. And I need to also remember that I'm multiplying. So it really doesn't matter how I arrange it. When I multiply it out, it's going to still give me the same answer. If I factor out a 3, I have x left over, plus sign left over. 3 goes into 6 twice and bring down that y. What do I do to my first parentheses? You just bring it down because it's all multiplied. This is also written in factored form. So that's a vocabulary term I need you to start locking in. When I see 3 times x plus 2y times c minus 3d, that is when everything is times each other, that's written in factored form. So it's very important to know that word. $109. And we're still factoring the expression. We have 8a to the third minus 2a squared minus 4a plus 1. I see 4 terms, so I want to first think about factor by grouping. When you're factoring, because we're going to talk about a lot of different ways to factor, the first thing you want to identify is, can I find a GCF out of all 4 terms? And the answer is no. The next thing you need to say, okay, how many terms do I have? And that tells you which method to use too. I see 4 terms, so when I see 4 terms or maybe 6 terms, I think about factor by grouping. So I do want to apply my factor by grouping. Right here, in my first part, they both have a 2 in common and they have an a squared in common. We're dividing, so we got to subtract those exponents. 2 goes into 8 4 times. 3 minus 2 is just a. Bring down my minus sign. The same, S-A-M-E, same divided by same is 1. Now, whatever this sign is, write it down next. This one's a little tricky because I got 4a plus 1. They have absolutely nothing in common except 1. So you have to bring down that minus 1. 1 goes into 4 times, and bring down the a. Right here, very careful. Negative times what is positive? A negative. And 1 goes into 1 how many times? 1. One thing I want you to notice is that if I do my factor by grouping correctly, what's in parentheses match every time. If it doesn't match, it means that you may have worked it out incorrectly or you have to rearrange your group. So the first thing you want to do, if these do not match, see if you did your math correctly. If you did your math correctly, you may have to do a little rearranging with your terms to make it work out like this. Now look at your two parts again. What is my greatest common factor? 4a minus 1. What was the uncommon factors? 2a squared, and then that minus 1 you must write down. So if something cancels out to 1, you need to write 1. Okay, so this is our lesson on 5.1. Please continue working on your homework and study over these notes. And if you have any questions or concerns, please let me know.